Hello, I'm Kevin Morley, Manager of Federal Relations at the American Water Works Association, and I would like to welcome you to this session on cybersecurity in the water sector. This session is intended to help prepare attendees of workshops that we have developed to introduce and advance the water sector's understanding of cybersecurity. More specifically, the approach that AWA developed for the water sector based on guidance from water utility subject matter experts and in collaboration with the Departments of Homeland Security, U.S. EPA, and the National Institutes of Standards and Technology, or NIST. This effort originated with the AWA Water Utility Council and is supported by the Water Industry Technical Action Fund and the Department of Homeland Security. So now I would like to turn things over to Jeff Colson with EMA, who is providing technical support to AWA in developing these resources. Jeff?
Thank you. My name is Jeff Colson. I'm a practice director with EMA Canada. I have 20 years experience in process control system design, programming, and implementation. 15 years of those are specifically in the water and wastewater sector. The purpose of this webinar are to understand how cybersecurity events could impact water utilities, to learn the drivers behind the cybersecurity assessment and using the AWWA cybersecurity guidance tool, to provide a brief overview of the cybersecurity guidance tool, which is how the tool is used and what is required, to prepare attendees for participation in a cybersecurity seminar and to use the cybersecurity e-learning module, and to identify who should attend the seminar or complete the e-learning activities and what documentation would be beneficial for the seminar and what is needed to complete the execution of the tool. The webinar is split up into 3 modules. The first, to review the drivers for cybersecurity. The second, to introduce the cybersecurity guidance tool. And the third deals with preparation for the seminar or the e-learning activities. The learning objectives for the webinar are split between the 3 modules. Following Module 1, you should be able to explain why utilities should complete the cybersecurity assessment using the AWWA assessment tool and explain the drivers for using the cybersecurity guidance tool. For Module 2, you will be able to explain the application of the cybersecurity guidance tool and how the use cases are used in the execution. And following Module 3, you'll be able to identify what system information will be discussed in the application of the use cases and identify who should attend the seminar or use the e-learning module prior to conducting the cybersecurity self-assessment. So, reviewing the drivers for cybersecurity. Why does it matter? Cybersecurity has been identified as the greatest threat facing business and critical infrastructure in the United States. This is reflected in Executive Order 13800, strengthening the cybersecurity of federal networks and critical infrastructure, that was introduced in May 15, 2017. This order complements the NIST cybersecurity framework that was prepared under Executive Order 13636 on February 19, 2013. This executive order enhances the security and resilience of critical infrastructure by protecting the control systems and the business systems also, and it reduces the risk or consequence of a cybersecurity attack. Risk can be either mitigated or dealt with or insured. In this case, we are trying to reduce the risk and mitigate the impacts. So we have 2 examples. The first example is Lansing Board of Water and Light. These are a cybersecurity attack that was a ransomware attack on the Lansing, Michigan utility. This utility provided water and electrical to a large number of clients. The attack was made through a virus introduced to a business system computer through an email that an employee clicked on, a very common phishing attack. At this point, the virus encrypted all of the files on the computer and spread to other machines on the network. And a demand for payments in Bitcoin was then made to release the files. This was dealt with by Lansing Board of Water and Light, but the cost was significant. A $25,000 equivalent ransom was paid, over $400,000 in PC server replacements and IT activities, and an overall cost estimated at over $2.4 million. On the positive side, there was no loss of customer information reported. This does indicate that these controls are about risk management versus risk elimination. BWL was somewhat prepared for the attack, but no amount of controls or preparation can make you entirely immune, but you can lower the consequence and the impact of any attacks. The second example cited is the WannaCry ransomware attack. Similar to the Lansing, this was a ransomware attack where the virus was introduced into the computer system, and computer users were then met with the screen demanding payment. This specific attack was built on a Microsoft vulnerability that was patched 2 months earlier. The attack was very successful in Europe and less so in North America, as it targeted older machines that were not patched. This is an example where patching and maintaining a good cybersecurity program would reduce that risk. So to review the drivers for cybersecurity, the water sector infrastructure and systems are critical to the nation's security, economy, public health, and safety. That is the driver behind the executive order. Plants and water systems are now highly automated and are not staffed to operate in a local mode if all control systems were removed, impacted, or in some way inoperable through the virus. The water infrastructure itself, with its reliance on mainly Microsoft operating systems and standard hardware, are susceptible to cyber-based risks. Managing cyber-based risk requires cybersecurity guidance that promotes or requires actions that enhance the confidentiality, integrity, and availability of computer systems. By using the cyber assessment tool, recommendations are identified to help manage these risks. At risk in the water sector are the business systems, such as customer service, billing, finance, in addition to the control networks. But all of these systems are vital for the ability to deliver essential services, without which communities could suffer significant economic, environmental, and health and safety impacts. So to summarize Module 1, the threats of a cyber incident are real and have been experienced in the United States. The risk and financial impact of a cybersecurity incident can be very high without having controls and protections in place. And the water plants, the control systems, and even the business systems are critical infrastructure. Moving on to Module 2, we will discuss what is the Cybersecurity Guidance Tool. The tool is a water sector specific guidance tool to manage cyber risk. It is based on industry standards that include Department of Homeland Security, National Institute of Standards and Technology, International Organization for Standardization, and the International Society of Automation. All of their standards are referenced and used in the Cybersecurity Guidance Tool. This tool is in alignment with the NIST Cybersecurity Framework. The tool uses use cases that are used to define the system to determine what controls are applicable. By using this tool, it helps facilitate discussions between operations, IT, management, SCADA, and other staff about cybersecurity and the operation of the process control system. The output of the tool is a prioritized list of recommended controls based on the use cases. So I will talk now about the use case approach. The tool itself is a web-based tool. You select use cases that match the elements of your system and your practices from 5 categories: the architecture, how the system is built and connected; the network management and support systems, the switches, the routers, all of the support activities and maintaining them; program access, how people are accessing the system; PLC programming and maintenance, and also HMI programming and maintenance; and then user access. You select use cases from each of the 5 sections. To select a use case, you need in-depth knowledge of your current system, organization, practices, and technologies. More in-depth discussions about the use case selection is presented in the seminar and the e-learning module. Displayed now is the Cybersecurity Guidance Tool page on the AWWA website. The tool is available directly from the website and is accessed with an AWWA account. Included on this page is a PDF document which has an overview of the tool and a guide for the execution. So now we'll talk specifically about the use cases. A use case characterizes the manner in which the utility uses the control system, and it deals with how the system is used by operations, by engineering, by management. And it asks a number of different questions, such as, is remote viewing available from a different location or from outside of the control room? Can the system be controlled from a different plant, a different location, or outside the control room? Are there control system interfaces and automatic data exchange? Are internal business system interfaces used to provide process data to other systems, such as providing runtime data to a work management system? And are there external interfaces, such as remote sites in a pumping system or internet access on the process control system to provide information like weather data? Answering each of these questions as part of the use cases will map how the system is configured and will produce the desired controls. But selecting the applicable use cases requires knowledge of the system architecture, what functions are used, and how these interfaces are configured. Moving on to the controls generated by the tool. The security controls are measures developed from many industry standards. These controls reduce risk through a variety of strategies, such as the organization, procedures, and technology changes. The tool prioritizes the recommended controls and correlates each control to the industry standards. A control would be made up of multiple standards or can be a single standard. When you select your use cases, the tool is going to generate a prioritized list of recommended controls in an easy-to-use and share PDF document. At this point, we'll go through some examples of the 4 priorities of controls. A priority 1 control is the minimum level of security for a SCADA or process control system. These are the must-have controls. If these controls are not in place, the system is significantly at risk, and these controls should be implemented as soon as possible. An example of a priority 1 control is requiring unique usernames and passwords for system access. Do not use operator to access your control system. A priority 2 control provides significant and immediate increase in the security of the organization if it has not been implemented. An example are critical cybersecurity policies and programs that govern the use of the process control system and requirements for cybersecurity awareness and other training requirements. Awareness of phishing attacks and other virus or attacks upon the system are critical for staff to understand what they should and should not be doing with the control system and business systems. Priority 3 control provides additional security against cybersecurity attacks on the PCS system. These controls provide a foundation for a managed security system and a cybersecurity program. These controls are not as critical as priority 1 and priority 2 items, and should be implemented as part of a cybersecurity improvements program as soon as budget allows. Examples of this would be implementing a cybersecurity asset management program and a cybersecurity document and policy management program, where all policies and documents regarding cybersecurity in the system are managed, updated, and reviewed, and all of the assets within the system are tracked, managed, and updated. And finally, priority 4 controls. These controls provide protection for specific sophisticated attacks, which may be less common, and also provides policies and state-of-the-art protection mechanisms. These controls are dealing with risks that are less likely and also are providing the policies that are needed, but following the implementation of the more critical items. So, as a summary, The cybersecurity guidance tool is executed by applying use cases to your system and policies to identify how your system is used and what controls will be applicable. The use case describes how the control system functions, and the controls identify what is needed to be in place to protect them. The controls are automatically generated by the tool and are prioritized by impact, also benefit of implementing the controls, and risk. This brings us to the final module, preparing for the seminar. This will identify how you can receive the greatest value from the seminar or the e-learning session. So what is needed for the seminar? The seminar and e-learning module will present information on how to select the use cases and how to use the inputs. So to execute the tool, you will need all of the following information that is shown below. You do not have to have all of that information to attend the seminar or to view the e-learning session, but it would be beneficial so you can identify if there are any gaps in your knowledge before you start actually executing the tool. So examples of documentation and information would be telecommunications, network architecture and security architecture drawings, governance processes, risk management policies, business continuity and disaster recovery preparedness plans, server and workstation management practices, access control procedures, application security and data encryption practices, access control or physical security details, and any service level agreements with vendors and internet service providers. Again, this information is beneficial to have as a reference for the seminar, but is not fully required to attend the seminar and the e-learning module. Next, who is needed for the seminar? The participants can also include directors and managers, and again, operations and maintenance managers, utility directors or managers, IT director or IT staff, and technical staff who are directly involved with process control system, including network administrators, application managers, a SCADA, PCS administrator, and a server and workstation manager. Not all the staff may attend the seminar or use the e-learning material, but a sample of staff across the three areas is recommended. Operations staff are critical for the seminar and for executing the use cases. The staff will review or participate in the use case presentations. The operations staff have knowledge of how the system is used on a day-to-day basis, what interfaces are used, where some of the information is going, how data is moved back and forth, what people are asking them for. Operators participating on the team will see how the controls and outputs are generated and how this may impact on the day-to-day use of the system, as implementing a new control may restrict a function of the system which is currently operational, but introduces a cybersecurity risk. Knowledge of the guidance tool process through the seminar or the e-learning activity will help operators provide inputs to the execution of the tool and understand how the controls are going to be used in the future. For managers, inclusion of management staff will provide them with an overview of cybersecurity and how it impacts their water systems. They will gain understanding of the cybersecurity drivers and participate in those discussions. They will see the value in assigning staff hours to attend the seminar and to complete the tool execution. And they will see how the outputs of the tool can generate assessments and cybersecurity projects that can work to provide them with a long-term cybersecurity program. IT and SCADA staff will participate in the use case presentations and have all of the details on how the architecture, both the control system architecture and the network architecture, are implemented for the system. They will also gain an understanding of cybersecurity drivers. They will see what additional documentation and knowledge is required to complete the execution of the tool, and what current practices and processes are in place, and what improvements or additional processes and practices would be needed. And they can help move the controls and outputs into cybersecurity improvement projects. Summarizing Module 3. Attendance at the seminar or e-learning module will provide education and knowledge to use the tool and to apply the controls to all staff who attend. Both technical and operations staff are needed to complete the execution of the tool, as both sides look at the control system differently and may use the control system differently. And finally, seminar and e-learning module participation will help identify the documentation, information, or knowledge that is needed to execute the tool. As a summary for the webinar, we are looking at 3 main activities that we completed in the modules. We reviewed the drivers for cybersecurity and for threats. We provided an overview of the use case concept and the control output, and we identified staff and information that should attend the seminar and e-learning module prior to executing the tool. Now that the webinar is complete, for the seminar or the e-learning session, you should be ready to answer the following questions. What is a cybersecurity driver for your utility? Is your control system connected to the business system network? Is the internet available from any of the control room's clients or servers? Do you know who should attend the seminar or e-learning workshop? And do you have a network architecture drawing? If you can answer these questions, you are ready to attend the seminar. If you do not have a network architecture drawing or do not know how your systems are connected, you should have someone who could answer those questions in attendance at the seminar or the e-learning session. So if you can answer all those questions, we'll see you at a seminar soon.